In this lesson, I'm going to do what kind of relations are functions. And if they are functions, you need to find the domain and range. So I'm going to start with the first one, -2, 0, -3, 3, -4, 8, 0, 0. So the relation can be expressed as an ordered pair. And that's what is given in part A, ordered pair. And there is multiple ways of finding whether this is a function or not. The one way you can do is you can make a mapping chart. So in that, your x values here is -2, -3, -4, and 0. So when you make a mapping chart, you make sure that you arrange them in an ascending order. So that is -4, -3, -2, and 0. And then your y values here is 0, 3, 8, and 0. So when we have more than one value which is repeating, we write down that only once. So that is 0, 3, and 8. Now -4 is mapped to 8. So I'm going to make a mapping. So it's like an arrowhead here. -3 is mapped to 3. -2 is mapped to 0. And 0 is mapped to 0. So here, this is a function. So first of all, each and every element of x has to be mapped to the y values. So that is the first condition for a given relation to be a function. The second condition is that you cannot have, for one input, you cannot have two outputs. So this is called input. X values are called input and y values are called output. So for a function, one input cannot have two outputs, okay? But two inputs can have one output. So in this case, -2 is mapped to 0 and 0 is mapped to 0. So two inputs can share a same output, but one input cannot have two outputs. So this is a relation. Now to find the domain, so this is domain and this is the range. So this is range. Again, you have to write down whenever you are writing it in ascending order. So -4, -3, -2, 0. And then for range, it's equal to 0, 3, 8. Again, repetition. We do not repeat any number here. Now for part B, again, you can either make the mapping chart, which I did here, or you can look at, because here you can see 5 is mapped to -1 and 5 is mapped to 3. So same input is mapped to two outputs. So 5 is mapped to -1 and to 3. So it's not a function. Okay. Now the next one is y is equal to 4 minus 3x. Again, you can see here, you can graph it. Graphical is the another way. So from graph, you can also see if it is the... You can also see from graph if it's a function or not. So if I sketch this graph, y is equal to 4 minus 3x. And if I graph it, it's a linear function. And if I draw a vertical line here, here graph, and if I draw a vertical line here, and you can see from here, it passes the vertical line test. And what does that mean? That when you are moving a vertical line across the graph, then there should be only one point of intersection. And as you can see that as we are moving, that the point of intersection, there is only one point of intersection, which means, and in fact, this is one-to-one function. For one input, you will have one output. So graph is the another way you can use to find out whether the given relation is a function or not. Y square is equal to x, which is same as y is equal to plus minus square root of x. Again, we can use the graphical approach here. So I can graph second square root of x, and then I have to do is negative second square root of x. And if I graph it, and it will not pass, okay. So y is equal to, let me see here, negative square root of x and graph. Okay, so if I draw again the vertical line, second draw vertical. So for drawing vertical line, I'm going to second and program and then enter, and then using these cursors you can see it's for vertical line it has more than one point of intersection, in this case 2, so it's not a function here. Okay, this is one way of finding the graphical approach. The another one will be if you look at -1 and 1. So if x is -1, then your y is going to be, so -1 and 1 will get mapped to 1 in this case. Okay, so again, because x is equal to y square here, right? And from here you can see if x is -1, okay, which is, you can't see here, but if x is equal to 1 here, then you will have y is equal to, if x is equal to 1, let's see, x is equal to 1, then y square is equal to 1, y is equal to plus minus 1. So for x is equal to 1, you will have, it is mapped to 1 and -1. So that's why it's not a function as well. Okay, so you can use the graphical approach here. Okay, now here from the graph, which of these shows the relations that are function? For those you have to find the domain and range. So here again, if I do a vertical line test, if I draw a line here and if I move it, it has more than one point of intersection, in this case 2, so this is not a function. And in this one again, so here it's fine, but the problem here is on this one, because for x is equal to 1, it is mapped to 1, and for x is equal to 1, it is also mapped to 2. So 1 is mapped to 1 and 1 is mapped to 2. So not a function again. And here in this case, again, if you move a vertical line test, it passes, so it's a function. And here again, when you do this, because this point is included, it's a piecewise function. This dot means this point here, 4 is included here, but 4 is not included here. So it is also passes through a vertical line test. So this is also a function. Now, if they are function, we need to find the domain and range of those functions. So for C, for this one, the domain and range. So you can see here, it's like keep on going. So x belongs to R and the range is also y belongs to R here. Okay, in this case, x belongs to R is the domain, but y is the range in this case. So this is domain. Range is all the integer values. So y is integer values. So that is going to be, so here the range is going to be like this: 4, 3, 2, 1, 0, -1, -2, -3, -4. Okay. Now here, so for this one, number 1, domain and range. So here, domain and range. In this case, domain is 2, 3. The x value for this point, this is x is 2, 3, 4, and 5. That's the domain of this range. This is 1, this is 2, 3, and 4. So 1, 2, 3, and 4. So for domain, you have to see on x-axis what are the x values this graph took. And for range, we look at the y-axis. So for here, the y coordinate is 1. For this one, y coordinate is 2. Here it's 3. It's 4 here. Now, in this case, the domain of this is x belongs to R, except x is equal to -2. Or the another way of writing this is x belongs to R and x is not equal to -2. That is your domain. And for range, y belongs to R except y is not equal to, except x is -2, except y is equal to 0. So again, y belongs to R, but y cannot be equal to 0. From the graph, you can see that there is no value where y is going to be equal to 0. Now this one, domain and range. Here x, now these dots means this graph starts from here and then ends from here, or start from here and ends from here. So here the x value is 2, here x value is -3. So here the domain is all x. This line means such that x belongs to -3, 2, and these are -3. As you can see, these are open circle, so these points are not included. So this is the one way you can express this. Open bracket means -3 and 2 is not included. Or you can also use this one. This is also means -3 and 2 is not included. Now range here is y such that y belongs to -5, 2. Now here this -5 again, since this point is not included, so -5 is not going to be included, but 2 is included. So when included means these brackets, okay, and excluded means this, or you can use these brackets, same thing. Okay, now here domain again and range. So domain in this case, -3 and 1 is included. So which means -3 less than equal to x less than equal to 1. That's your domain. Again, you can express like this, or you can do -3, 1, and both of them are included. Range in this case is -4 less than equal to y less than equal to 0. So here you can see this is -4 and this is 0. So the height of this graph is between -4 and 0, and -4 and 0 is included. Or you can express -4, 0, closed bracket. Okay, that's it for this lesson.